Okay, from the definition of instance and database, we will go to the next level where we will see the overall picture of architecture. So just to recap, instance is nothing but system global area, a memory structure, and combination of background processes. Background process occupy this memory structure and make it as instance. And instance manages the database, which consists of system data and application data, right? So let's go into the bigger picture of the entire architecture. So if you're looking at the entire architecture, you have on the database side data files, which are primarily data files, control files, and read log files, which are in kind of gray color. Now, other than the database files, you also have parameter files, password files, and archived log files. These are out of database files. You can call them as a system files, system required files, but not part of database. Now, when it comes to the background processes, we have pmon, smon, database writer, log writer, checkpoint, and others. In the system global area, again, there are divisions where you have database buffer cache, redo log buffer cache, a shared pool. In shared pool, you have library cache and data dictionary cache. No, and in the bookish way, I could go ahead and define what each one is, but that won't give you a good understanding. Rather, I would like to explain you this with a simple user actions and how these background processes come into play and how the um, buffer cache will be considered. Let's start with simple database. Okay. In For example, we have a database with employee data, right? A company is just starting out, and earlier they used to maintain data in the Excel sheet, and now as the company grow big, they're going to use Oracle, and they put employee data into database. Okay, and that employee data which is in the hard disk, which is in a permanent memory. Whenever a user queries for these data, he runs SQL statements. For those SQL statements, instead of the giving the data directly from the file system or the file database file, the database writer background program will read this data into database buffer cache. And from there, it will give to the user. Why does it do that? Well, if it's directly reading from the file, it can have the files can be handled with one user for read writes. But if it's in cache, one, it's faster. Two, multiple users can be managed to read from the same buffer cache. So once the data is read from the file system to buffer, it speeds up for the next users who are using the same set of data. So that's the reason it captures the required data into buffer cache. So the database buffer cache simply whatever data is there in a particular data file requested by user will be captured, will be buffered into database buffer. Okay. So now the user has seen the employee data, and the next step is going to do is update this data. Okay. So he said, okay, I have employees and the company is going to give salary hike 10%, and he's going to run a update statement. Okay. Update employee salary equal to salary multiplied by 110. Oh, this is wrong. Well, this company is going giving 110% hike. It should be 1.10. Well, if they do give that kind of salary, I definitely want to join there. Uh, that would be nice, don't you think? Well, when you run this update statement, what happens is database buffer already has employee data. Instead of making changes for the salary data, it copies the data in the redo log buffer and make the changes before the data change and after data change will be done in the redo log buffer. Okay, and why does it do that? Again, if at the same time when you are doing update statement you haven't if the user has not committed it or rolled back it, so it during this time any user who is coming and requesting the same set of data that need to be given before the salary changes were applied from the user one. So for that reasons it copies into redo log buffer. If redo log buffer gets full, the log writer program writes it back to persistent memory log file. It not only in case of full, even if the user is waiting for a long time, there is another program called checkpoint program, which is running as a background program again. Will check back after set of time which you set it in your parameter file. During after that time, if no changes were done, for making sure the read access memory data not to be lost if the power is gone, it writes back these changes to persistent memory. Okay, so in this action we are seeing data file and log file, database writer and a log writer, which are background processes, database buffer and redo log buffer. Okay, if the user has committed the data, then the redo log changes which are committed will be written back to database buffer, and eventually database writer will write back to the data file as a persistent. But um, if if for any reason, if these changes were not the committed changes were not written for database buffer or data to back to data file, there is a system change number which is recorded on data files and log files. When the system, if the system goes down during this time, when the system is coming up, the um, control file, which we're going to discuss in very soon, will tell that the system change number is not same on both the files, and it asks for log files which has the latest changes to be applied back to the data files first, and then the system will come to the consistent stage to be opened for all the users. So again, we're defining data file, database writer, log writer, which are background processes, and database buffer and redo log buffer. All right, so from there let's go to the next section.